Hi, everybody. Ready for chapter 10? Today we're going to be talking about radicals, which means square roots and other kinds of roots. But first, a quick review of exponents and how they work. And if you need more than just a quick review that I'm giving you here, you can go back and look at chapter 5, especially section 5.1 and 5.5 in the book that really explains exponents and the properties of exponents and how they work. So, exponents, that's when you have an expression like 2 to the 6th power. The little number up here is the power or the exponent, and that tells you how many of, in this case, the 2 to multiply together. So 2 to the 6th power means 2 times 2 times 2 times 2 times 2 times 2. When you multiply that all out, you get 64. X to the 5th power would mean x times x times x times x times x. That is 5 x's multiplied together. If we have something like 13x to the 5th power, the power only applies to the x, not to the 13, because powers or exponents come before multiplication in the order of operations. So 13x to the 5th means 13 times x times x times x times x times x. There's only one 13, but 5 x's. And negative x to the 4th power only applies to the x, not to the negative. It's like a negative 1 times an x to the 4th. It's negative x times x times x times x. What about 1 to the 10th? What would that be equal to? Well, if you multiply 1 times 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 1, you get 1. What about 7 to the 1 power? Well, that would just be 7. Any number to the 1st power would just be that number. Now notice the pattern here. 10 to the 1st power would be 10. 10 to the 2nd power would be 10 times 10, which is 100. 10 to the 3rd power would be 10 times 10 times 10, which is 1,000. 10 to the 4th power would be 10 times 10 times 10 times 10, which is 10,000. So every time the power goes up by 1, we multiply by another factor of 10. Or if we went the other direction, every time the power goes down by 1, we divide by another power of 10, by another factor of 10. So 10,000 divided by 10 gets you 1,000. 1,000 divided by 10 gets you 100. 100 divided by 10 gets you 10. And if we keep going, 10 divided by 10 would get you 1. So according to the pattern, 10 to the 0 power ought to equal 1. And if we keep on going, 1 divided by 10 would be 1/10. And then 1/10 divided by 10 is 1/100th. 1/100th divided by 10 is 1/1000th. So notice what happens when we get into negative powers of 10. 10 to the negative 1 power is 1 over 10. 10 to the negative 2 power is 1 over 100. That is, it's 1 over 10 to the 2 power. 10 to the negative 3 power is 1 over 10 to the 3rd power. It's 1 over 1,000. And the same sort of pattern works with powers of any other number. I just used 10 for an example, but I could use 4. Every time the power goes up by 1, you multiply by 4. Every time it goes down by 1, you divide by 4. So 4 to the 0 power is 1. 4 to the negative 1 power is 1/4. 4 to the negative 2 power is 1/16. So it's 1 over what 4 to the positive 2 power would be, and so on. So the general rules here, if you take any non-zero number to the 0 power, the answer is always 1. So what's 258 to the 0 power? Answer 1. And if you take any non-zero number to a negative power, that's equal to 1 over that number to a positive power. So 9 to the negative 2 power is equivalent to 1 over 9 to the positive 2 power, 1 over 9 squared, or 1 over 81. Now we have some various rules or properties for the way exponents work. One of them, often called the product rule for exponents, because it's about a product or what you get when you multiply things together. It says that a to the m times a to the n equals a to the m plus n. When you're multiplying, you add the exponents. So for example, x to the 2 power times x to the 5 power is x to the 7 power. And that's because x to the 2 power means x times x, times x to the 5 power means x times x times x times x times x. And when it's all multiplication like that, there are 7 x's being multiplied. The quotient rule for exponents says a to the m divided by a to the n equals a to the m minus n. So for example, x to the 6th power divided by x to the 2nd power is equal to x to the 6 minus 2, x to the 4th power. That's because if you take x times x times x times x times x times x and divide by x times x, those 2 x's on the bottom cancel with 2 of the x's on the top, and then you have 4 x's left, x times x times x times x. Then we have the power of a power rule that says if you take something to a power and then take that to another power, that's equivalent to multiplying those powers together. A to the m to the n equals a to the m times n. So for example, x to the 5th power to the 3rd power would equal x to the 15th power, x to the 5 times 3 power. And the reason that works is when you take x to the 5th power to the 3rd power, you're multiplying 3 x to the 5th powers together. So you're multiplying xxxxx times xxxxx times xxxxx, and altogether that's 15 x's being multiplied. Then we have the power of a product rule. A times b to the n power equals a to the n times b to the n. So you can multiply first and then raise to a power, or you can raise each individual factor to that power before you multiply. So for example, x times y to the 6th power is equivalent to x to the 6th power times y to the 6th power. And the reason that works is you've got xy times xy times xy times xy times xy times xy, 6 xy's multiplied together. And this is all multiplication, so we are allowed to rearrange the factors. We can multiply in any order. So if we rearrange these so that all the x's are together and all the y's are together, it's x to the 6th power times y to the 6th power. And the power of a quotient rule says that a over c to the nth power is equivalent to a to the nth over c to the nth. So for example, x over y to the 3rd power is equivalent to x to the 3rd over y to the 3rd. X over y to the 3rd power, which would mean 3x over y's multiplied together. But if you remember, when you multiply fractional expressions, you can multiply the numerators, multiply the denominators. So we get x times x times x, or x to the 3rd on top. We get y times y times y, or y to the 3rd on the bottom. So that was our review of exponents, what they are, how they work, the properties and rules of how exponents combine with each other. And now I will stop this video here and pick up in the next video to talk about actual radicals, square roots and cube roots and other kinds of roots. See you then.